Hey folks, welcome back to another video. Today we're looking at question 1161, maximum level sum of a binary tree. The way we'll be solving this problem is by using BFS. So we'll use a queue to keep a track of the number of nodes that we need for a given level, add them up, and compare it to the previous values that we have seen. A relatively straightforward problem, so let's jump right in. The first thing that you need to do is actually have those values that you can check again. So let's do long max sum. And the reason why I do long is because, for example, if there's an edge case where all of the numbers that are in the binary tree are integer max value, and adding them up doesn't really, you can't really store that in an integer. So that's the reason why you use long. And I would recommend doing this for um, anytime you need to add up integers, and usually it's like a edge case for a lot of them. And the other thing, the value that I want to assign to it initially would be integer min value, and the reason why I'm doing that is because here you see there are negative values in the root, in the elements, so that's the reason why we'll assign integer dot min value to that. Yeah, and then let's store the current max level as well. Int max level, that can just be 0. All right, so let's start off with the base case. So let's say a root, if it is equal to null, you just want to return a max level because you don't really care. And then if not, you create a queue. So the queue will be useful for BFS. The things that you need to store in it are the tree nodes. So let's call it queue. It's a linked list. Awesome. So classic BFS, you go in and you check, hey, while the queue is not empty, keep having fun with it. The first thing that you need to do is actually get the size of the queue. And the reason why you do that is because you want to understand how many nodes are in the current level. So let's say, yeah, so once you have the size, you would just say int I equals 0, I less than size, increment I. And the other thing you also need is the current sum. So let's say long sum equals 0. And then you pop, you remove the node from the queue. So node current, let's call it. It will be queue.remove. And yeah, you just add that to the sum. Sum equals current dot value, and you need to add the children of this given node to the queue. So let's do that. But the first thing you need to do is actually check. So if queue dot left is not equal to null, then you would add it. So queue dot add, or is it? I guess you can add it. Queue dot add current dot left, and you do the same for right. Not equal to null, queue dot add current dot right. Awesome. So let's get back to the size part right here. Int size is equal to queue dot size. All right. So the reason why we need to actually get the size of the queue is because you see here you're actually adding the children of the given nodes in the queue back to the queue. So to make sure that you don't calculate more than the current level, that's the reason why you need to keep a track of the size of the current queue and then add up only those nodes. Awesome. So once that part is done, the for loop is done, the next part you need to do is actually check the sum value, right? So if let's say sum is greater than max sum, what do you need to do? You need to update two things. You need to update max sum to be equal to sum, and then max level would be equal to oh, that's something that we need to do. So let's say int level equals 1. So we need to start off with 1 because in the question it says the level of the root is 1. So it would be level. And once you're out of that loop, you need to increment level. And that part should take care of all of the calculations. And in the end, you would just return max sum. Awesome. I think that should be okay. So let's compile this and see if it's okay. Oh, no. Oh, right. Sorry. We first we don't need to return max sum. We actually need to return max level. And the reason why it was complaining is because it actually needs an int that we are passing back along, but we don't really need to. So anyway, so max level. Let's try compiling this again. Huh. Expected is 2, output is 0. Why? Oh, we didn't add this. Oh, in the beginning, before you actually jump into the while loop, you need to add the root level, obviously. Okay, so this should be okay. Okay, so the first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the solution. The time complexity of the entire solution is of n, since we have to go through every single node in the tree to get to the result, and the space is also of n, since we are using a queue here to keep a track of the tree nodes that we need to analyze at the next level. Yeah, so if you have any questions about the problem, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It keeps motivating me to make more videos. And if there's any question on LeetCode that you would like me to solve, please let me know in the comments as well. Thanks so much, and